Hello, everyone, and thanks for joining us today for the Kubernetes Storage discussion. We're excited to have you all here. I'm Martha Guerin, one of the technical sales directors for training at Atmosera. Today we're joined again by Mike Hacker, the app innovation specialist for the state and local government at Microsoft. A little background about Atmosera, in case you're new to us. Atmosera is an Azure expert managed services provider, the highest Azure accreditation a partner can achieve. And there's only about 60 of us in the world, so we're pretty excited to be one of them. We also have a consulting division that works closely with Microsoft, and we align with a few of their core practices, including DevOps, app modernization, app development, Azure infrastructure, and data and AI. And our training team works closely with the Microsoft teams as well, and we can provide customized trainings for pretty much anything you're looking for. We often pair our training with the consulting to provide collaboration and knowledge transfer. Today's speaker, Ron Samita, is one of our top trainers and my go-to for consulting as well. So through the continued partnership with Microsoft, Atmosera is eager to help the SLG community develop and enhance their Kubernetes skills. We are recording the session today, so if you happen to miss part of it or you have a colleague that's interested in viewing it, then please let us know and we'll be happy to send you out the link. If you have any questions, please put them in the chat window. We'll be answering those throughout the next couple hours, and most of the last 30 minutes of today's conversation is going to be strictly Q&A. If you'd like a follow-up consultation with an expert, let me and Nikki know, or please contact Mike as well. So thanks again for joining us. I'm going to turn the floor over to Mike Hacker from Microsoft.
Well, good morning, good afternoon, everybody. Thanks for joining us today. And once again, thanks to our partner Atmosera for hosting this event. We really appreciate all of their hard work that they put into these events. So once again, my name is Mike Hacker. I'm an Azure App Innovation Specialist for Microsoft State and Local Government. I've got over 30 years of software development experience. I've been with Microsoft for over 13 years. Specifically covering state and local government customers. I focus primarily in kind of our north central region of the US. Now, my email address is listed on the screen there, so if you have any questions, you want to reach out directly to Microsoft, feel free to email me. If you know who your Microsoft account team is, I would recommend emailing them or at least CCing them on any questions that you might have, because they'd be able to probably help you a little bit quicker with your specific account questions. I do have a link there, blog.mikehacker.net, so a kind of a shameless plug there. Out there I post some different training opportunities and events that are going on, such as this, for you to be able to take advantage of. So please definitely check that out. On the left side, there is a training link too, so check that out because there's some really good, deep training resources that you can get access to for free to learn a lot more about these types of topics. So why are we talking about containers? Well, we had a conversation and a great webcast previously, kind of diving in a little bit into Docker, and we're kind of continuing that with this conversation on Kubernetes. And it's really important because we're seeing that containers in general is really playing a strategic role in organizations. And whether these organizations are already at the point where they're using containers or they're looking to use containers, it's really becoming that strategic way of packaging up and deploying these applications. It makes it easy to move between environments and move between clouds as needed. And when you're looking for hosting these applications, Microsoft Azure provides a wide range of solutions for building and hosting containers, such as Azure Kubernetes Service and Azure Red Hat OpenShift. And so if you're looking to learn a little bit more about those, we have a link there, docs.microsoft.com/learn, which is one of the links you'll find in that training section on my blog to help you learn a little bit more about these different technologies that you could use for hosting containers. Now, as I mentioned, if you need any additional assistance, please reach out to your Microsoft account team. We have lots of different resources to help you not only understand what the different features and capabilities are available to you, but also help you walk through and look at potential architectures and decisions. And of course, also reach out to Atmosera. They're experts in this area, and they can definitely help you really accelerate your journey to the cloud and your container technology journey. So with that, I'd like to turn it over to Ron to kind of jump right into the topic.
Okay, thanks, Mike. So here's what I'm planning to cover in today's session. We're going to be first looking at what a Kubernetes volume is. I'm assuming coming into this that you already know a little bit about Kubernetes, the fact that it's a container orchestrator. So here we're going to focus specifically about Kubernetes storage. Starting with what a volume is, we'll look at why you might want to use Kubernetes volumes, and we'll talk about the two major categories of volumes, which are ephemeral volumes, examples of which are empty dir, downward API, config map, secret. For those of you who are a little bit familiar with these topics, I'll tell you the ones that I'm going to talk about in detail specifically in this talk. We'll look at empty dir. We'll also talk about config map, but I will at least make a mention of secret, since that is a very critical one for you to be aware of, at least that it exists and what its limitations are. And then in the second part of the talk, we'll look at persistent volumes. So in other words, ones that survive beyond the lifetime of an individual pod. And with persistent volumes, there are three major concepts that you need to know about and three major constructs that you will need to create in order to effectively use them. So we'll talk about the persistent volume, which is created by the administrator to indicate what storage is available. The persistent volume claim, which is, or PVC, which is created by the user to indicate their storage requirements. And then of course the pod that uses the PVC, which in turn gets bound to the persistent volume, or PV. And that's another thing we'll be talking about, is that binding process, how that binding process between the PV and the PVC, how that actually works. And then we'll talk about two forms of persistent volumes, Hostpath volumes and local volumes. And I'll do a little bit of a contrast between the two, but specifically I'll be demoing Hostpath volumes, so at least you get a sense of how the PV and the PVC work. And then one last issue we'll talk about is how to go about deleting the PV and the PVC. There are aspects of that deletion process when you go to do the cleanup that are not completely obvious, and so that's why I added a few slides at the end of this talk in order for me to discuss all of that. So first, let's start from the beginning and talk about why you might want to use Kubernetes volumes and what these are about. So Kubernetes volumes are basically files in a container that are by default ephemerals, which means that they are lost if the container crashes, and they are not shared between pods. And Docker storage, if you look at that, if you've had some experience with that, is exposed as a directory or file in the container. And there are three major types of Docker storage. So you might wonder, well, why have Kubernetes volumes? Why deal with Kubernetes storage when there's already existing Docker storage at a lower level? And the three major types of Docker storage are bind mounts, volumes, and tempfs mounts. Now, the story with these three, just as a brief summary of them, is that if you wanted to have storage that is one where you share it, let's say, between containers, then bind mount would be a way to do that. That is stored in a Docker managed area. You have volumes, which are another way that you can operate with Docker storage, where you can specify the directory and you share it with the host. And then tempfs mounts, which are in-memory storage, basically, for Docker. All of this infrastructure exists in Docker, but one of the problems with it is it's got limited functionality. And as you'll see with Kubernetes storage mechanisms that we're going to talk about in this talk, there's a whole wider range of options and support for a whole variety of different scenarios. For example, Mike mentioned a moment ago, Azure and AKS. There are specific infrastructure bits available for working with Kubernetes volumes in conjunction with Azure. So the greater flexibility of Kubernetes volumes is a big reason why you might want to look at using this. So now that I've mentioned the term Kubernetes volume, what exactly is it? Well, it's a directory that contains 0 or more files that's accessible to containers in a pod. And there are many different kinds of volumes that are supported. Depending upon the volume type that you choose, that determines how the directory is created, what backing store is used, and the contents. And a single pod can use multiple volume types. So you're not just restricted to having a single pod being able to only use one volume type. It's certainly possible to have a single pod that can use multiple volume types. And looking at the various volume types that are available, there's a pretty large list of them if you look at the Kubernetes documentation, which I've linked at the bottom of the slide there. But you can divide these volume types into two general categories. Ephemeral volume types, where the lifetime is tied to that of a pod, and which are destroyed when the pod no longer exists. And then persistent volume types, which are ones that exist independent of the lifetime of the pod, and where the data is retained when the container is restarted under the covers. So if you want to get some sense of the various volume types that are available, I put this link at the bottom of the slides. Let me go to that link briefly so that you're able to get some sense of, in the Kubernetes documentation, what is available. And as I scroll down through here, you can see there's a section called Type of Volumes, where they list some of the major volume types that are available. Notice that you see as you flip through this that there's support for the major cloud vendors. So AWS is in this list. So they have various volume types of volumes for AWS. They're the Azure ones that immediately follow alphabetically. So you see all the various Azure ones listed here. And then they have some other third-party ones, but I want to highlight a few of them that we're going to be talking about in this talk. Config map, I'm going to talk about that in a few minutes. That's a very important one, very commonly used if you want to be able to inject configuration data into your pods. That's where that one would be used. And downward API is another one. I'm not going to talk too much about this one, but you should be aware at least that it exists, which makes the downward API data available to applications, is what that one is about. Empty dir, this is the first one I'm going to be demoing to you. Then that's a volume that's first created when a pod is assigned to a node and exists as long as that pod is running on that node. So this is an example, canonical example of an ephemeral volume type would be empty dir. And as I scroll through this, you can see, just get a sense as I scroll through how many there are. Notice that there are a bunch for the Google Cloud as well, various volume types for that. One of the problems I have with this, which I'm addressing later on in this talk, this documentation page specifically, is there's a pretty large list, as you see, and it's alphabetically organized. So if you are new to Kubernetes storage and you are wondering, well, which one should I use for what I'm trying to accomplish, it can be difficult to navigate through this. So it would have been nice if they had categorized it in multiple different ways and indexed it rather than strictly alphabetically, but by purpose or by category of some sort. They didn't do that, but I've done that later on in the slides. So toward the end of this talk, I will show you how I've organized at least the list of what you see here, so that hopefully will help you navigate to the proper type of volume that you want to use for a given scenario. But let's start by talking about a few of these, and beginning with the ephemeral volume types. So I mentioned how these ephemeral volume types are ones where they remain until the pod is removed from the node. The data is then permanently deleted, and this idea of it remaining until the pod is removed from the node does not apply, however, to a container crash. Container crash does not remove the pod from the node, so therefore that would not necessarily cause the ephemeral volume type that you're using to go away. And just as I was flipping through the list of those volume types on the doc page a moment ago, I highlighted empty dir, which is the big one that we're going to start with, which is an empty volume that's created when the pod is assigned to the node. There was downward API, which I highlighted as I went through that list, and config map, which is what I'll demo second. And then while I'm not going to demo it because it's a bit more involved, at least I'll tell you a bit more about it, which is the secret volume type, which is used for passing sensitive information to pods. And I always like to tell developers to be aware of that and to be aware of what it can and cannot do for you. So that's a big part of the reason why I at least want to talk about that within this session. But let's start with this empty dir volume type, which is an initially empty volume that's stored on the same medium that backs the node. So in other words, an example of how this can be used is it can be stored in RAM. And to do that, you would have to set the empty dir.medium field to memory. And that way you're basically backing empty dir volume by memory, by RAM. And the containers within a pod share the data within the volume. So that this is a way for you to have sharing between containers as long as they reside inside of a single pod. And empty dir would be a way to make that happen, because containers don't natively share anything, but empty dir can be used as a quick and dirty way to have sharing between containers. Remembering, however, though, that empty dir is going to be deleted permanently when the pod is removed from the node. So this would not be the mechanism to use if you want that storage to be persistent. If you want that, then you will use what is discussed in the second part of this session. But you might wonder, well, what are some use cases for empty dir? Well, I mentioned one of them a moment ago, where you want to share information that doesn't need to be persisted between containers within a pod. Other use cases would be scratch space, a recovery checkpoint for a long-running operation. That's a very good example of where empty dir makes a lot of sense. because you want to be able to, as you're doing a long-running operation, maybe log out what you've done so far, so that if something goes wrong and you need to recreate and get back to the state that you were in before things went bad, then you have at least a way through empty dir for you to be able to see that information, or some sort of temporary cache, right? But again, remember, if it needs to be persistent, this is not the mechanism for you to use. But if it's something where you're just storing something, let's say in memory or something temporarily while operations are occurring, then empty dir is a very good candidate for a Kubernetes storage mechanism. In order for you to use Kubernetes ephemeral volume, you need to specify the volumes to provide to the pod. Assuming this you're doing this in a YAML file, that would be under the spec field and then a volume subfield underneath there, where you would indicate the volumes you want to provide to the pod. And then you also need to indicate where to mount the volumes into containers. And that is done, again, under the spec field, but with a container subfield and then a volume mounts field. And this can be specified inline in the pod spec, and that then simplifies the deployment and the management. So to make this more concrete, here is an example of an empty dir pod definition, where we're defining a pod. Notice that the container we're going to use the Ubuntu image. So remembering a bit of Docker, that up in Docker Hub, you have all these various images out there. Here we're leveraging the Ubuntu image, and we're going to create a container based on that image that we're going to call container 1. Need to say a few important words about this command field and what its setting means. If you've looked a lot at Docker and you played around a bit with things like the Ubuntu, using the Ubuntu image to create a container from it, one of the issues that you'll run into if you just very simply create a container based on that image without a whole lot of command line flags, then an issue you're going to run into is that that container will run, but it'll immediately exit. So a very well-known technique for keeping the container from exiting is to use the --c command and specify as a string tail-f/dev/null. You don't necessarily need to know all the intricate details of what that does. I'll just summarize for you in plain English what this command is intended to do. It's intended to keep the underlying container running so it doesn't immediately run out and exit, right? In reality, the way this is working is you're basically saying that you want to keep internally a file open and dev/dev/null. If you're a Linux developer or worked a lot with Linux, you already know what that is. But basically, this is a way of saying just wait for the file to have additional contents in it, but it's never going to completely exit. So that's exactly what we want. We want to just keep this container alive, and this command that we execute within the container will make that happen. And for example, when I talk about Docker, that's one of the things I often do is I'll do demos where I use exactly that command --c and then as a string tail-f and then /dev/null, and that's just a means of keeping the container alive. But here's the important part for what we're discussing here. This volume mounts field, where we specify the mount path, which is going to go into a directory within the container called /app, and then the name of the volume mount, which we're just calling empty dir volume. And then under the spec field, we also have a volume subfield where we specify that same name, empty dir volume, with the empty dir field as just being empty going in. All right, so in other words, there's going to be no contents in that app directory within the container initially. But we'll go ahead and put something in there, and then we'll see how when we get rid of that container, that storage goes away altogether. When we get rid of the pod, more precisely, right? You don't normally manipulate containers directly at this level where you're dealing with Kubernetes, but under the covers, there's that container there. And when the pod goes away, of course, the containers go away as well. And very importantly, any empty dir storage will also go away. So what I'm going to do is put this into a demo. I'll grab the contents from that slide and stick it into a YAML file that I will use from this command prompt that I have right here. So just so you know, what I've already done prior to this talk is I created up in Azure an Ubuntu VM. And with that Ubuntu VM, I installed Docker, I installed Kubernetes, and I just want to check this. I always tell people in the classes I teach on Docker and Kubernetes, before you do any significant operations, and I'm using Minikube, just for simplicity, I'm using Minikube to create for me a single node cluster. I always tell people, before you do any critical operations like I'm about to do right now in this talk, run Minikube status and make sure that everything looks good, that everything is up and running. Because one of the problems you can sometimes run into is if for whatever reason the single node cluster that you're dealing with got stopped, then things fail, and sometimes fail pretty cryptically. So I'm just checking before I do anything else that everything is up and running. And I did all of this before this talk so that I wouldn't have to spend a whole lot of time talking here about configuration, right? All right, what I'm going to do, because I'm going to be doing a fair amount of manipulation of YAML files, is I could use the local Linux editors. For example, VI. I used VI in my undergrad and grad school days, so those keystrokes are very well bound into my memory. But given how much I do with Visual Studio Code, I'm actually going to use code for this, just because I think it's a whole lot easier ultimately to manipulate things in code. It's a little easier for you guys to see it as well. And so let me close up what I've got running here. This is some Azure AD B2C work. I do a ton of B2C lately. In fact, I do that more than anything. But let me close up this folder, and then I'll show you how you can get into that Ubuntu VM storage and manipulate it from Visual Studio Code. If you attended my last talk that I gave for SLG, I did show this, but I'm guessing there's a number of you who are in this talk who are not in the last one, so I'll just quickly demo it again. And this is just a necessary bit that I need to do to connect to that VM and be able to create files and edit files, but by effectively SSHing into that VM that I also have an SSH session into through the Windows terminal. And basically what makes all this work, as either a quick review if you were at my last talk, or if you weren't, then an introduction to what I'm doing here, which is I'm using a very cool extension, which is this remote SSH extension that comes from Microsoft. Notice this is not some random third-party thing out there that you might need to be a little bit leery of. This is a Microsoft extension for Visual Studio Code that is ideal for this type of scenario where I am SSHing into my Ubuntu VM that I created up in Azure, and I want to be able to both see the directory and files that are in that Ubuntu VM. In other words, I want to be able to see this content that I'm looking at the top level directory here and be able to add directories and add files. Well, the secret is either hit F1 with that remote extension installed, or click in the lower left corner on the green button that you see here to open a remote window, then choose Connect to Host, and then specify, and I need to go and look up the login info right here for the IP address and the username that I'm using for that Ubuntu VM. So I'm just specifying that information right there. A new Visual Studio Code session will pop up, and in a few seconds, usually takes a second or two because it's got to connect. So here it tells me it's setting the bits up for it, and then I have to specify my password that I would use normally in any SSH session. One thing that I don't so much like here, I may not have typed that in correctly. One thing I don't so much like about this is they don't give you any confirmation when it actually works. Sometimes either I'm typing this in wrong, or I may just have trouble connecting. And if this fails, then I'll go and use VI. Sometimes I've had this happen to me. Let me try it one more time. And I can just use the VI editor, worst case. It would be nice if I could do it this way, but I will give it one. I'm going to come in and just copy that bit out and go back to Visual Studio Code here. And we'll try to do a connect to host like that. One thing, oh, that was probably the mistake. I had a space. That's one thing very critical. If you do copy the username and IP address like I did here, make sure there's no space in front of it. Otherwise, you will literally get what I had there, which is it won't give you any error other than when you try to type in your password, it will continue to tell you that, or continue to prompt you for the password until it does it like 3 times, and then it fails. But now I should be good. There we go. And in a second, hopefully, this will do the SSH connection. Now, one of the things I was just getting ready to tell you that I'm not so fond of is that they don't give me any confirmation that it worked, other than you have to look in the lower left corner here, and if you see the same place that you clicked on in the first code session, if you see SSH colon and then the IP address that you were connecting to, that means it worked, right? That means you are connected. And then the next step is click right there to bring up the Windows, the Explorer within the Explorer tree view within Visual Studio Code. Click on Open Folder. You're going to be prompted for number one, the directory that you want to initially get into when you do the SSH through code. The default is exactly what I want, so I'm going to say OK. And then you're going to be prompted a couple more times for your password in a second. And again, this process usually takes a second or two. And then there we go. There's the password prompt. It'll prompt you twice more for your password. So let me make sure I put that in correctly. There it is the first time. And then, oh, there we go. Okay, so the very first time you do this, it'll prompt you twice. Since I've already done this before with this VM, that's why it's not prompting me a second time. And right now, I'm actually looking at the content that, the equivalent content to what I see here in my SSH session from the command prompt. And it's really the equivalent of if I did an ls-a, because all the various dot files and directories don't show up natively when I do an ls. But looking here, they all show up on the left-hand side underneath this tree view. And so now I'm all set. I don't have to worry so much about dealing with the Linux editor and the dealings with that. I can just do everything the exact same way with code that I use code for everything else. And given how many different technologies I'm working with, and you get a sense of that by looking at my extensions that I have installed into code, I use code pretty much for everything. And this is the main reason why I'm using code for this demo, is that it makes it easier for me since it's very consistent with what I'm doing with all the other technologies I'm using on a day-to-day basis. All right. So now that I've got all the infrastructure set up, let's create a new folder for this demo. And again, you just use this exactly the same way as if you were using Visual Studio Code on your local machine. But remember, it's really manipulating things onto that Ubuntu VM. So I'm going to call this first empty dir demo. Empty dir demo is what I'm going to call the directory. And just to show you this too, if I do an ls, you'll see that directory listed there, right there. So it's very cool. This is the first time you're ever seeing this very cool thing that we're able to use code just the same way we would off our local file system, but in reality, we're manipulating files and directories out onto that Ubuntu VM. All right, I'm going to create a new file within here now, which is really what we were seeking to do to begin with. I'll call it pod.yaml, and I'm going to take the contents of that slide and put it right into this pod.yaml file, right, like this. And I'll save that away. I've already gone over with you what the contents of this actually means. And then let's just cd to that empty dir demo. And I'll do an ls on it. Verify pod.yaml is there. And then I'll do kubectl apply -f on pod.yaml. All right, what I want to do is check to make sure that the pod is created successfully. So I'll say get pod. And I can see it's already up and running, so that is a good sign that we can see that that's there. And now what I want to do is show you that because of what we put into the YAML file, that we created this empty dir volume, that there is a directory within there called app. And then that directory right now is empty, but we'll put some contents into it just so you can get a sense of that directory being created as a result of creating this empty dir. All right, so how do I get into now that container within the pod? Well, here's the command you can use to do it. It's kubectl exec-it, because I want it to be an interactive terminal that I want to get into that pod. I called it empty dir-pod, and then I'm going to need to specify --bash. I'm also going to put this in, even though I only have one container, because in the next demo, I'm going to show you how you can go about setting up an empty dir as a means of sharing information between two containers within a pod. I'm going to put this in to indicate which container I want to get the shell into. And if you notice back to the YAML, I called the container, the single container I have in this pod definition YAML file, container 1. That's why I'm putting in -c container 1 there. Let me hit that. We get a shell into it. If when I do an ls, I expect to see an app directory inside of here. It's exactly what we have. There's that app directory. Let's cd into that app directory, and I expect to see no contents in here because we specified that the empty dir is going to have no contents with this last field setting that you see there. All right, I'm going to create something inside of here just so you can see at least that I can put some content in here. So I'm just going to say echo hello into greeting.txt. All right, and then I'll just cat that greeting.txt bot like this, and that hello contents is there. All right, now one of the points behind this though is I'm going to come in, I'm going to blow away that pod right now. I'm going to kill it. So I'll do kubectl delete pod empty dir dash pod. So that will then delete the pod. It takes a few seconds for it to completely delete. Keeping in mind, and the underlying reason for that is that empty dir is part of what we put into that pod. So it's got to delete that along with deleting the pod itself. And that's part of what I'm trying to show you in this demo right now. And I never like to sit around just waiting idly for something to happen. So I'm going to do this just to verify whether it's gone away yet. I'll do a kubectl get pod, see whether it says it's terminating. It's still, I see 1 of 1. So I'll do a -w when I run it so that we can look at the status and see when there's a status change on it at some point. And again, I don't like to sit idly waiting for something, but my goal is to recreate the pod and show you that in the recreated one, that the file that we created, greeting.txt, is not there anymore. This is taking an inordinately long time, the first time I'm doing it. All right, here's just a screenshot. I'll go back to the slides for a minute while I'm waiting on that. Here's a screenshot of what I just did, the procedure that I just did a moment ago, including that kubectl exec-it empty dir pod-c container 1 and then --bash after that, and looking at the contents of that app directory. Let's see if any status has changed here. I'm going to do it this way: kubectl get pod empty dir pod-w. Let's look at that. Oh, it's gone. It's gone now. Okay, so I'll do a get pod command and just verify. Yeah, no resources found in default namespace. It is gone now. I'm going to go ahead and recreate it with that same kubectl apply command. And all we care about for this is just seeing that the storage that we have now, there's going to be an app directory again. So I'll do exactly that same kubectl exec command. But that empty directory, that empty dir volume, is not going to have any contents inside of it. The contents from the previous creation of the pod is lost. That's the important part to see in this demo. So once again, I'll come in, we'll look, see app is there, but nothing inside of that app directory, right? So that's showing you that the storage really is ephemeral, that even though we created that empty dir, we created a file inside of that app directory, but when I blew away the pod, that means the empty dir went away along with it. And that was my guess as to why it takes so long to delete this pod, because ordinarily pods are very quick to get rid of. All right, so I'm going to go ahead and delete the pod again, and then we're going to create it a little bit differently with the next demo that I'm going to do of using empty dir. So this is what I want to do right there. We know that's going to take several seconds, but while we're waiting on that, I'll move on to the next slide and show you the next bit, which is using empty dir again, but as a means of sharing between containers. Because in the last demo, all I had is a single container. Now what I want to have is 2 containers, both of which use the same empty dir volume. And therefore, if I were to put content into that directory, then one of the containers, I can see that in the other. That's what I'm going to show you in this next demo. So here's the YAML that I'm going to use for this one. In fact, I'll just modify the existing pod.yaml file that I have here into what I want it to be for this demo. And as I talk about it, I'll copy the contents from the slides in. Right? So there's that. And then this is the second part of it. And it's very similar to the last demo. Oops. Now, one thing you've got to be very careful of, even just copying content like this, remember that in a YAML file, indentation matters. White space very much matters. If you get the slightest bit of white space off at all, then it fails. And that can be very difficult to diagnose. So be very careful with making sure that you have everything aligned perfectly in terms of white space. As a note about this, by the way, normally when I do these demos like this, I like to dynamically type things in to show you starting from nothing and creating everything. I wouldn't even try that with a YAML file. YAML files it's just too picky in terms of the white space, too likely that I would make an error if I tried to type something like this in from scratch, right? So this is why I'm copying it. Even copying and pasting it as I'm doing, very critical that I be careful about making sure, for example, when I did that copy, that I copy the entire first line, not just a part of that first line. In fact, this is so picky that, and I don't have time to talk about it in this talk, but I'll just tell you a little bit about this. If you read some of the documentation about YAML files and Kubernetes specifically, then I've even seen things that say best practice is not even to type a YAML file in, but two major ways. One, start from a YAML file that is you can find online that's close to what you want and modify it into what you need it to be. Or option two, you can start from the CLI, start from the command line interface, create a simplified version of the resource that you are looking to create within Kubernetes, and then you can just go ahead after that resource is created and use the -o flag and specify that you want YAML, -o YAML, and that will allow you to see the YAML for that simplified form of the resource, and then take that YAML, copy it, put it into a file, and then modify it into what you need it to be. But I wouldn't ever try to start from any non-trivial YAML file definition, just typing it all in from scratch. It's just too difficult to get everything exactly right, and way too error prone, is bottom line. All right, so this definition, I have two containers, container 1 and container 2. That's the difference between the last demo and this one. Both of them are using that same command to keep the container alive. But here's the critical thing. Both of them are using volume mount field underneath spec containers, where the first of the two containers, container 1, mounts to /app. Container 2, which is defined here, mounts to /app2. So we're not specifying the same mount path in the two containers. One of them, container 1, is app, and container 2 is app2, but both of them are specifying the same empty dir volume, which is specified down here, and with the same type of definition that we had in the last demo. All right, so that's the YAML file. That's the new twist on it, is the fact that I have two containers, both of which share the same empty dir volume, but mount to different mount paths. All right. And what we're going to see when I go ahead, and now the pod has been deleted, when I run kubectl apply -f, did I save the file? I did, pod.yaml. Then at this point, I want to just verify once again that two things. One, that the pod is created. So I'm going to say kubectl git pod, and it is created. And number two, that we have two containers within that pod running, and that's exactly what we've got. And now what I want to show you is if I get a shell, a bash shell into container 1, which we'll do the same way that you saw before, kubectl exec -it, and I'm going to specify empty dir pod -c container 1. And here's where the -c really matters, because I need to specify which one of the two containers I want to get the shell into, and then --bash. So I get the shell into it. I expect to see an app directory inside of here. It's exactly what I have. I'm going to cd to that app directory, do exactly what I did in the last demo. Echo hello, redirect to greeting.txt, verify that that greeting.txt file contains that hello string in it, and it does. And then I'm going to get out of here. And here's the interesting thing now, when I exec into container 2, so exact same command I did a moment ago, but I'll change the -c flag to say container 2, get a bash shell into container 2, what I'm expecting to see here is two things. Number one, that there's an app2 directory inside of here. Again, back to the YAML file, note that when we define container 2 inside of here, we specified the mount path as app2 there. That's why I'm expecting to see an app2 directory. It's exactly what we have. We have an app2 directory there. And when I cd to that app2 directory and do an ls, I expect to see that greeting.txt file here, which is showing you that we're sharing between two containers within a pod because both of them mounted the same empty dir volume. And there we go. Greeting.txt is there, and I want to verify that the same content is there as well, which is that hello string inside of this file. It's exactly what we see. All right, I'll just do one last thing is I'm going to change, for this demo at least, I'll change the content now to goodbye that is in that file. So I'll echo goodbye out to greeting.txt. Then I'm going to go into the first container and see that now the file that we see in the app directory does show goodbye instead of hello. So let's cat it first, just to verify that we see goodbye. I'll exit out of here. I'll come into container 1. Notice I'm using container 1 here, get a bash shell into that. App directory is still there, of course. CD to app. Take a look. Greeting.txt is still there. Let's do a cat on greeting.txt. And sure enough, I see goodbye. So that's showing you that you can use empty dir as a way of sharing information between two containers, as long as you don't need that information that is shared to be persisted at all. Because what I'm about to do next is the same thing you saw me do in the first demo that I did with empty dir, which is I'm going to blow away once again the pod, and that means the empty dir is going to go away along with it. So that greeting.txt file that was there will not be there, right? So kubectl delete pod empty dir pod is what I want to do. All right, and we'll wait for that to go away because we already know that that's going to take a while to kill everything. All right, so here on the slide is just what I did in the demo, where there's the kubectl apply -f command. Here is the two kubectl exec commands, -it commands, first to get into container 1, put some content into the file inside that we create inside of that app folder, then get the bash shell into container 2, and then see that there's an app2 folder there, and inside of there is greeting.txt with the same contents that we set from the shell in container 1. Right? So that's the first example of using Kubernetes storage with empty dir. Now let's look at another example, which is using a different form of a Kubernetes volume called config map. Config map is a very, very well-known Kubernetes storage mechanism that's useful as a technique for injecting configuration info into a pod, right? In just about any real-world program, you're going to end up needing to specify configuration data somehow. The standard way to get configuration data into a pod is this way right here using config map. And this is referenced, again, if you're setting this up through a YAML file, in a spec field with a volume subfield and then a config map subfield underneath there. And you can specify the path for the specific entry. This is then going to be used by containers that are running in the pod. Very important thing about config maps is that they have to be created separately and created before they are used. All right. And the command to create a config map is kubectl or kubectl, depending on how you want to pronounce it, create config map, and then the name you want to assign to the config map. Now, there's a bunch of command line flags that you can use, but in my case, I'm going to be setting up a file that is going to represent the configuration data that I want to inject into my pod. And if you want to specify it from a file, you can use the --from-file flag and set that equal to a file which has the contents that you want to inject in. All right. So here's what I'm going to do for this upcoming demo. Just one last side note before I launch into the demo itself. The text data for a config map uses UTF-8 encoding, but you can use binary data for other encodings if you would like. All right, so first step is I want to create a config map, but I want the data for that config map to be a file, a simple hello world type of index.html file. And the reason why I'm going to use this as an example of creating an index.html file is the actual underlying container that I'm going to use, a container image I'm going to use and create a pod that has a container that is running from this image is Nginx. If you're familiar with the way that the Nginx image works, it actually listens for a request, listens for an HTTP request to come in, and then serves back an index.html file in a well-known directory path within that Nginx container. And I'll be showing you what that well-known directory path is. It's the user share, it's underneath user share. And then there's a subdirectory underneath there, HTML subdirectory, where they look for a file called index.html. And what I want to do in this demo is rather than having, in fact, I'll just go ahead and create a quick Nginx, create an Nginx deployment really briefly, just to show you how it in general works. And then I'll show you specifically how I'm going to customize it by injecting in a config map inside of there. Right? So I'll just do a kubectl create deployment, just a brief review of Nginx, since I'm going to be using this for the subsequent demos and the remainder of this talk. So I'll do kubectl create deployment. I'm going to call this Nginx deployment. And then I'll specify -- image equals Nginx, like that, right? Says the deployment's created. Let's take a look at a couple things. Kubectl get deployment. And just verify that, yes, the Nginx deployment is there. The pod looks good. We see ready 1 of 1, so that's all good. And at this point, I want to look at the pod. So there's the name of the pod specific. I'm gonna do exactly what I did in the last demo. I'll do kubectl exec-it and get into the pod like this, right? -- bash. And then when I'm inside of there, I'll curl for http:/localhost like that. And that is what is being served up, all right? So I wanted you to see first the default way that the Nginx works when I use it with a deployment in Kubernetes, without any special settings other than trying to create the simplest possible deployment. But I wanted you to see, once I get a bash shell into the pod itself, that I can curl to http localhost from there, and it's going to serve up this HTML file. Now, what I'm going to do is inject in configuration information with my own index HTML file, so that rather than serving this up and having this come back to me when I get into the pod and do a curl to localhost, it's going to serve up the index HTML contents that I want to specify. That's the difference, all right? So now that you know what we're shooting for, let me get out of here. I'll delete the deployment, Nginx deployment, which will then take out the pod too. But let's just get rid of the whole deployment so I completely clean up. Let me just check get deployment to make sure it's not there anymore, and it is not. And also we'll just check the pod status just to make sure there shouldn't be any pods, and we don't see any pods either. All right, step 1, I got to create some form of an index HTML file to make this look realistic. I don't feel like typing in one, and I want to make it look realistic enough, so I'm going to go to Visual Studio for a moment and use it to just generate the basic structure of an HTML file. And while I'm waiting for Visual Studio to fire up completely, let's go to Visual Studio Code that I have running right now. And right there it is. And I'm going to create a new directory. Let's see, I can use this existing directory, that's fine. But I want to create an index.html file inside of here. Index.html. All right. So there it is. And then I'll just use Visual Studio as a way for me to get that basic template for HTML file. So I'll say File New, and I'm going to choose the second one, HTML page. It's a good, quick, and dirty way to get basic HTML template is all I'm looking to do with Visual Studio here. All right, I'm going to copy that content, stick it into here, and then I'm going to just put in a title just so that we know that this really did work. So I'll say, hello world from config map demo, like that. All right, let's save that away. Now I have my own custom index HTML page. I'm done with Visual Studio. I'll just close that up right now. And then I'll come back to the command prompt and we'll do a kubectl create config map. All right, now a couple of things about this create config map command I want to make you aware of, like I was mentioning. One, I need to specify a name for my config map. I'll go ahead and use the same name that was used here, Nginx config. That's a good name because it reflects what we're doing in this demo. And then the other part is --from-file. I need to point it to the file that I just created, which is index.html, like that. And config map. Oh, I had a config map already laying around before with this name. Let me kill that. Just so you know I'm not cheating, I'm going to delete the config map with Nginx config that I had before when I was testing it. Config map, kubectl from snap. Oh, misspelling of kubectl. Okay, there we go. We'll blow away the existing one I have. In fact, let me make sure I don't have any in there. Config map. There is, other than this one, which you do not want to mess with, right? That one's already there from Kubernetes infrastructure, so you don't want to mess with that one. Now I'll recreate the one I want to create, which is here. There we go. And then I'll run git config map. And now I can see my Nginx config map there that I just created 4 seconds ago. So I know that this is a brand new, newly created one. Here's how you can see what a config map looks like if you're brand new to this. I'll do a describe on config map, Nginx config, Nginx-config. And the interesting part of this is that here's the contents of the index.html file that I created a moment ago that says hello world from config map demo, right? Exactly what I was typing into Visual Studio Code a moment ago. But what this config map does is it has key value pairs. And if you use, as I did in this command when I created it, if you use --from-file, what it's going to do is it's going to use the file name as the key, part of the key value pair. And the actual file contents will be the value. So essentially what a config map represents is a set of key value pairs. Depending on how you initialize it, if you initialize it as I did, just saying, hey, I've got this file, it's got a bunch of data in it, and I want this data to be all the value part, and I want to specify some sort of key, and I'm happy with that key being the file name, then you just run it the way I did here. There's a bunch of other flags, and you can see this when you run kubectl create config map --help. You can see the various variants of the flags you can put in, and there is a way for you as well, depending on which variant you want to use, of having the file just have a bunch of key value pairs in it. Another technique is you can also specify a file as I did, but use a different key name other than the file name. So I'll leave it up to you to peruse through the help here to see the various variants of how you can run this with different flag combinations in order to give you a different behavior from what you saw here. But I'm perfectly fine with this default behavior as it exists. So at this point, we've created the config map. And now the next part is creating a pod, which has this contents inside of it. Let me, in fact, grab this so that I'll refer to that config map that I created a moment ago in this pod.yaml definition. So here's the new pod.yaml definition where we are creating a pod called Nginx pod and a container inside of there with that same name. And then it's based on the Nginx image. Here is the Nginx volume reference there, which refers to a volume defined here, Nginx volume, that refers in turn to that Nginx config that we just created from the command line a moment ago. The fact that we created, in fact, let's go back and take a quick look at this just to remind you that we called it Nginx config. That's important because that's exactly the name we're using to reference this volume on the last line within this pod.yaml file, right? The other significant thing is note where we are mounting to. We're mounting to this location, user share Nginx HTML. That is the default location where Nginx serves up the index.html file. Or another way to say that is Nginx out of the box is looking for a file called index.html inside of this directory path that I'm highlighting here. So what we're doing is we're basically injecting through a config map our own index.html file, and we're mounting it to that location. And because we know that that's the location where Nginx serves up the content from, what that means is if I go and save this away and then run, make sure I don't have any pods laying around that I don't need anymore. Yeah, I don't. Okay, good. And I'll do an apply-f on pod.yaml. This then means that when I get a shell into this pod, verifying that it's up and running, and then do a curl to localhost, just like I did when I ran a generic Nginx pod, then we should see our own index.html file served up. That's what I want to see. All right, this pod's up and running fine. Let's get to the shell into it. So kubectl exec -it nginx pod --bash. And then all I'm going to do here is curl http localhost. And sure enough, we see our own contents rather than the default index.html contents that's normally served up. And there it is right there, hello world from config map demo. All right? So that's what I wanted you to see as an example of using a config map. Is the two steps involved. Step number one would be for you to come in and create the config map itself. And we just did that by using this command kubectl create config map. And number two, defining a pod that uses in turn that config map and uses it to do something functionally, like in this demo, where we're replacing the standard HTML file that they use, index HTML file, with the one from our configuration. So that's the config map example. And I put in, once again, screenshots into the slides. So if you want to go and recreate what I'm doing in these demos, you'll be able to do that. I want to talk about one more important form of an ephemeral volume type, which is secrets. And this is a very important one to be aware of, because in most real world programs I see these days, people need to do this, which is to store sensitive data for the application and to somehow get that into your pod. But the question is, how do you go about doing that in a way that is best practice and considered safe? Well, as it turns out, that there's a storage mechanism in Kubernetes called secrets that is a volume type that's intended for this purpose, for storing things like passwords, connection string, keys. And the best practice in general for storing secrets is to separate them from your application, right? This is definitely something that I always encourage everybody to do these days. Do not embed secrets within your code directly. It makes me cringe when I think back to about 15 plus years ago, when I used to teach things like ASP.NET web forms. And I used to think about, we had a security module in that old course, and I think about the way that we used to talk about storing secret information back then, and it makes me cringe by today's standards, because you'd never do it that way today. The best practice way is to separate out your secrets from the application itself. Secrets are a way to create that separation, in that you can mount this as files. It's backed by a temporary file system. So be aware that this is not going to be persisted. And this is why, again, it's ephemeral, and it is not something you would want persisted, because, again, by persisting the secret information, that's potentially dangerous. So this is stored effectively in memory, but it's not actually going to be stored at all on a persistent storage medium directly. Now, here are some caveats. This is one of the big reasons I want to talk about this, because if you just casually go through the list of volume types that I was showing you earlier, and you look and say, oh, secrets, and you say, oh, let me try this out. Be very careful about a couple of things in regards to secrets. Number one, the fact that the secrets data storage is unencrypted, right? And it uses the API server's data store, which is etcd. This is accessible by anyone who has API access and is authorized to create a pod directly or indirectly. So the best practice, if you are going to use secrets, I'm not saying don't use them, but I am saying if you are going to use them, you need to be following a couple of very important best practices. One, enable encryption at rest, and two, configure RBAC, configure role-based access control rules around the secrets. In fact, let me take you to the documentation page for this so that you're able to actually see a little bit of what they explicitly say. They say this pretty much right at the top of the doc page, but I want to just highlight it because this is so important. So right here, there's a dedicated doc page on the Kubernetes IO website for secrets. If you just scroll down a little bit here, right here under the caution, it will say Kubernetes secrets are by default stored unencrypted in the API server's underlying data store etcd. Anyone with API access can retrieve or modify a secret, and so can anyone with access to etcd. Additionally, anyone who is authorized to create a pod in a namespace can use that access to read any secret in that namespace that includes indirect access, such as the ability to create a deployment, right? So in order to safely use secrets, they tell you the following steps. Read them very carefully and follow those steps, all right? So that is a big part of why I added these slides in. Even though I don't have time to talk fully about secrets, I wanted to at least make you aware, number one, that they exist, number two, about the caveats of using them. Now, a couple other things about this that I want to point out. One is, given the fact that this is not stored persistently, where should you store your secrets? I would recommend using something like the Azure Key Vault in order to store them. So Azure has a mechanism called the Key Vault. That would be the best place to store on a more persistent basis, things like passwords, connection string, software keys, things that you don't want getting into the wrong hands. A mechanism like the Key Vault or some equivalent would make sense for you to use. Also, and I'll talk about this coming up, there is this CNI, this item called, the entity called the CNI, And for the Azure Key Vault, there is a CNI for that, and an interface to it, basically, so that you can integrate between Kubernetes secrets and something like the Key Vault. All right, I'll talk a little bit more about that later on in this talk, but I wanted to make you aware of this. And one other reason why I like to point this out is that you have to be careful about things like secret information being stored up in RAM and not being encrypted. And I'll give you an example of why it's so critical that you know that. If you look back a few years, I recall that there was a very major, well-known hack that occurred to a major corporation that I'm betting a good number of you are customers of, and that's Target. I know I'm a very avid Target shopper. I go there at least once a week, often twice a week or more, to buy basic food items, things like that. But they were hacked about a little more than 5 years ago. I read something about that hack to try to find out how it was done, and it's very much similar to what we're talking about here in one sense. The way Target's IT infrastructure worked, and it's embarrassingly bad that they had this, is the network was set up such that if you got in one place, you can get anywhere, right? So if a hacker could somehow get into the Target network, you had access to everything. That was one of the biggest holes in the Target infrastructure. So much so, by the way, that after the Target hack, the CEO basically got fired, which, knowing that there was that big a vulnerability, in some sense, deservedly so. But basically, the way the hackers got in is through the HVAC, right? They were able to get in through the heating ventilation portion of the Target network. Once they installed their malware onto there, here's the second bit that they did. And this is the part that relates to what we're talking about here with secrets and storing sensitive information in RAM. The point of sale systems at Target at the time, if you went and you swiped your credit card, they would store the information, things like your credit card information and personal information about you, up in RAM temporarily. They were encrypting it, but there was a lag between the time it was in RAM and when the encryption hit. And the hackers were smart enough to know, or they must have had inside information on how those point of sale systems work, because otherwise, how would you even know this? They knew that there was that short interval of time when that sensitive information was sitting there in RAM unencrypted. And they designed their malware to use a technique called RAM scraping, where they scraped the information out of RAM in that brief instant of time where it was not encrypted, and then they just sent it off to their own servers, and that's how they did the hack. So there were two vulnerabilities there. One, they obviously knew that the information was sitting there unencrypted in RAM for at least a short interval. And number two, the fact that if you got in anywhere, you could go everywhere. And both of those what led to that big Target vulnerability. All right. So that's why, back to secrets now, you need to know, yeah, this stuff is not persistently stored natively, but it's not encrypted either. And that's why you need to enable encryption at rest. Very, very critical, knowing things like that there was this Target hack. Okay, let's turn to persistent volume types next. And here we'll talk about the storage mechanisms where you can actually have the storage stay around even after the pod that's using it goes away. With persistent volume types, there are two major parties involved. One, the administrator, who will typically create a variety of persistent volumes indicating the different characteristics of the storage that is available. So it's up to the admin to take an inventory of what storage mechanisms they want to provide to the users, and they will create a set of persistent volumes that reflect those storage capabilities. The user is the second major party involved, and the user needs to specify what storage capabilities they need. And this is done by creating what is called a persistent volume claim, or PVC. And the user will specify in that PVC, here is the access I need, here is the amount of storage capability, in other words, the storage space that I'm going to need. And they may even, depending upon how things are organized, specify things like the level of performance that they need from the storage. And then the user creates the pod that references the PVC, which in turn provides the spec of what storage capabilities are necessary. Then what Kubernetes has to do is come in and match the PVC with a corresponding PV. And that process of matching the PVC with the PV is called binding. So those are the high-level concepts involved with persistent volumes. So let's break each one of these down, starting with the PV, the persistent volume. This is a resource in the cluster for representing storage. It abstracts away the storage level details and maintains the storage implementation details, but it abstracts it away. And there are two major provisioning options for using PVs. The first is called static provisioning, where you have a range of PVs with different capabilities, and the admin goes and creates PVs to reflect that range of capabilities. The other is called dynamic provisioning, where you use storage classes when none of the static PVs meet the PVC requirements, right? So if you're an admin and you have a provisioner available, you have to have some sort of provisioner available. For example, up in Azure, there is a couple of provisioners available that you can use. But this is a way of basically saying, here is the general category of storage that I have, and when internally they cannot find a static PV to bind to, they can dynamically do a provisioning of a storage resource that will meet the requirements of the user. All right, and we'll talk more about that process of binding coming up in a few moments. Okay. But storage classes are a way for admin to be able to specify, here is the general categories of storage I have available. As an example of that, let's say that you have some very high performance, fast SSDs for storage. Let's say that you have some SSDs that are not as high performance, but decent performance, certainly better than the old mechanical hard drives, which you might also have available. So you might have storage classes, one called premium, one called regular, and one called slow, or something along those lines, or conventional. Maybe you don't want to use slow because that has a negative connotation. So you use a word like conventional, where conventional would mean effectively conventional non-solid state hard drives, mechanical hard drives. So that is an example of what a storage class, where you might have 3 storage classes to represent the general categories of storage available. Then you need a provisioner available that will provision the storage upon request from the PVC. Now, the PV's lifecycle, very importantly, is independent of the pod that uses it. So unlike the ephemeral storage that I've demoed to you up to this point, where when I blew away the pod, the storage volume goes away with it. Here, on the other hand, if I were to set up the 3 major parts that we were discussing on this last slide, the PV, the PVC, and the pod, if I get rid of the pod, the PV and the PVC stay around. They do not actually automatically get deleted by default. All right, so that's a big difference between this and what you just saw a moment ago with ephemeral storage. Looking at the PVC, this is a request by the user for storage. The user can specify the size, the access mode, and this is used as a volume by pods. What the cluster has to do is inspect the claim, find a bound volume, mount the volume, and it's not removed until it's no longer used by any pods, even if it's deleted by the user. Right? In fact, this is one of the reasons why at the very end of this talk, I'm going to show you a little bit about the deletion process, because there are parts of that that are not obvious, particularly in light of the fact that the PV and the PVC can certainly live beyond the lifetime of the pod. So deleting this is not necessarily completely as straightforward as what you saw with ephemeral volume types. Here are the various access modes. Remember on this slide here, we were just saying on a PVC, you can specify the access mode. What are the various access modes? These are the access modes that are available. Read write once, which means mount as read write by a single node. Read only many, which means mount read only by many nodes. There's read write many, mount as read write by many nodes, and read write once, which is mount as read write by a single pod. There is more limited support for the last one, read write once pod. You have to be using the container storage interface, and you have to be using the version of Kubernetes greater than or equal to 1.22. The latest version, if you install it like today, is higher than that. So you're not going to have to worry about that, assuming you have a recent installation. It's if you have an older installation, you might want to check the version number to verify that that version number is higher than 1.22 or equal to, greater than or equal to. Otherwise, you can't use read write once pod. Notice on this slide, I put in parentheses the acronyms for each one of these. That is important, because one of the things I'm going to show you when I demo this to you and create the PV and the PVC, you're actually going to see these acronyms used in the columns that are displayed when you do a get on it, a kubectl get. So that's why it's important to not just know what these are, but to know the acronyms for them. Keep in mind something else too, that in this demo, just for convenience, I'm using Minikube. Minikube is a single node cluster. So obviously I'm not going to be using the ones here that apply to many nodes, like read-only many or read-write many. Those apply to many nodes. It wouldn't make sense for me to use them. I can just, for example, use read-write once if that's what I want, as opposed to read-write, the read-write options, corresponding read-write options that apply to many nodes. I can certainly use them on in Minikube. I just want to make you aware, though, I won't be able to leverage that full capability on Minikube since it's a single node cluster. All right, let's talk about binding next. So binding, as I've mentioned, is the process of matching PV with a PVC, right? The user specifies the PV saying, here's the storage capabilities I need, and the admin specifies what storage is available through a PV, and they've got to match the two up. And the binding is exclusive. So that means that you cannot have a PV that is bound to more than one PVC. And the binding can be dynamic, which means it's automatically provisioned on request. And the PV is provisioned for a PVC. If a PV is provisioned for a PVC, it will always bind to that particular PVC. Now, the other way to do the binding is static binding, as I mentioned, where the admin makes the storage devices available to the cluster. And the requirement is always the case that the PV has to meet the minimum requirements of the PVC. It can always provide more than what is requested and still bind successfully, but never less. Right? Very important to know, if you are a user and you specify your storage requirements through a PVC, and it turns out that what is available at the moment is just PVs that don't meet the full requirements, no binding will occur at all. Right? In fact, they'll just hold it at bay until a PV becomes available that will meet or exceed the requirements of the PVC. You can pre-bind if you would like, which means setting a claim ref field in the PVC to specify a particular PV that you want to bind to. But even at that, the same rule that I went over a moment ago still applies. The control plane has to verify that that PV meets the minimum requirements of the PVC, and if it doesn't, that pre-binding will not occur. And the PVC will just remain unbound until they find a sufficient PV that meets the requirements of the PVC. So the admins can use these storage classes that I was talking about a little bit a couple slides ago to classify the different types of storage. This is the equivalent of profiles in other systems. And dynamic provisioning is based on these storage classes that are pre-created by the cluster admin. And the PV can specify a storage class name, and that means only bound PVCs that request that matching storage class name will be bound to the corresponding PV. And a couple of notes about this: if you leave off storage class name altogether, that on both sides, that constitutes a match, as long as, again, the PV meets the minimum requirements of the PVC. If you set storage class name equal to an empty string, that is not the same thing as omitting. In fact, it's the opposite. Setting storage class name equal to an empty string completely disables dynamic provisioning altogether. And the PV specifies the fields that are used when the PV of the class is dynamically provisioned. So one of the important fields is a provisioner. If you're going to use dynamic provisioning, you need to set up some sort of provisioner. For example, there are ones for Azure that use Azure Disk, right? Also, there's parameters and the reclaim policy, and I'm going to go over the reclaim policy coming up on a subsequent slide. But now I want to make this a little bit more concrete by showing you an example of a persistent storage volume type. And the one I'm going to demo to you is Hostpath. So what Hostpath is used for is to mount a file or directory from the host node's file system to the pod. Right? This is not one I would normally encourage you to use. It is typically best avoided because there are some security issues that I'll be talking about in a few seconds associated with it. But it's great for a demo to at least give you a feel for how these persistent volumes work. A better choice than Hostpath, if you want to do something somewhat similar, is local volume type, which I'll go over after I talk about Hostpath. But Hostpath fits nicely with the demo that I was just doing using Nginx and and serving up a custom index HTML file. So that's why I'm going to use this for the upcoming demo here. All right, so the use cases though for a host path would be if you want direct access to the Docker internals, for example, var lib docker directory, if you wanted to have your containers running in the pod with direct access to those Docker internals, then that could happen through a host path volume type. Also, for Kubernetes monitoring tools, certain monitoring tools might want direct access to some of the directories, then that's another reason to use host path. And this allows a pod to specify the creation details of the file or directory on the host node. That would be another use case for this as well. But why am I discouraging from using this? Well, one issue is security issues. This potentially allows access to privileged resources, right? I mean, if you think about what's going on, when you allow a container running in a pod in Kubernetes to mount a file or directory from the host node, that means a change on one side is going to affect the other, right? And you're also tightly coupling the two to one another. And also created files or directories are only writable by the root. So these are some of the security issues that you can run into when you use this. So while it is very convenient on one hand, on another hand, it's potentially very dangerous as well. And that means non-Kubernetes applications can affect implicitly the behavior of Kubernetes apps and vice versa when you use a mechanism like this where you are allowing a file or directory from the host node file system to be mounted directly into a pod. So that's why it's best practice to avoid the usage of this. If you do use it, scope it to a file or directory and mount it as read-only, because at least that's safer in that you don't have to worry about the fact that one side can write and that can have an effect on the other side. All right, so here is the set of steps involved if you want to use host path like I want to do in this demo for with persistent volumes as an example of a persistent volume. Number one, I've got to create the PV. Now I'm going to, just so you know the high level example I'm going to use for this demo, same basic thing I did with the Nginx demo earlier, where I want to specify an index HTML file. Now in the previous demo where I did this with config maps, I injected effectively in the index HTML file into the pod, right? Into the container, that Nginx container running inside of that pod. And that way, I knew the exact directory path where Nginx was looking for to serve up the index HTML file. That's how I implemented it in that demo. Here, I'm going to do it a bit differently. What I'm going to do here is, again, take that same index HTML file with a slight modification. I'll modify the title to reflect this different demo that I'm doing. But I'm going to specify the volume location on the cluster node, which will be /mnt/data, mount data, in other words. I'm going to put an index HTML file inside of there. Right? Then I'm going to create a PVC that will be bound to that PV. Both are going to use the same storage class name, and the capabilities of the PV will exactly meet those of the PVC. So therefore, the two can get bound to one another. Then I'm going to create a pod that uses that PVC. And that's how they're all going to get linked to one another. Then I'm going to, as an example, define a container using that Nginx image. And the web server is configured to listen on port 80, as you know. You saw that in the earlier demo I did where I just curled to a local host. And then I'm going to mount the volume at the default index.html location within the Nginx container, which, as I went over earlier, is user share Nginx HTML. And that way, when I curl, again, when I have a shell inside of the container, then I should see whatever content I have in that index.html file served back up, rather than the default index.html file being served that you saw the very first time I created an Nginx deployment in this talk. So this is what I have to do to mount a Kubernetes persistent volume. I got to specify the volumes to provide to the pod. Underneath the spec field, there's a volumes field. I'm going to specify it there. Where to mount the volumes in the container. We already know the locations, but this is the specific place within the YAML file, spec containers volume mounts, that I'm going to be setting up the indication of where to mount the volumes into the containers. And then I need to mount at specified paths within the file system hierarchy. Okay. And it's the Docker image at the root. Containers have to independently indicate the volume mount location. You never mount onto other volumes though. So there's no hard links, in other words, to another volume. All right, let's make this concrete, put this into a demo, starting with the PV definition. You'll finally, now that I've gone over all of those infrastructure bits that I need to talk about, I can finally show you a concrete example of a PV. I'm going to create a brand new folder for this demo, except not inside of the existing one. But let's create a new folder. I want to call this, let's see, I'll call it PV demos, good enough. All right. Actually, I'm going to call it Hostpath demo, because exactly what I'm demoing is Hostpath. All right. Inside of that Hostpath, I'm going to create the first of 3 files. So I want to call this one pv.yaml. And inside, in fact, let me close up the previous pod.yaml file to avoid any confusion. This index, I'm going to create something a little bit different for the index HTML anyway. So let's copy the contents from this PV definition that I have here into that file that I'm just creating here. A couple things about this I want to go over it with you before I move on to the PVC. First thing to note, the kind is persistent volume. The metadata is pv-local vol. Label is local, right? And storage class name. This storage class name needs to match up with the storage class name that I'm going to specify in the PVC. So keep that in mind. I'm just calling that manual. Here are the capabilities of this PV. The capacity, 1 gig of storage. The access mode, read write once. Remember, we went over the storage access modes a moment ago. So here we're specifying read write once. Very importantly, 2 things. Host path field underneath spec. This is what makes it a host path, is that field. And the second thing is, notice where we are specifying the path, /MNT/data. Keep that in mind. That's going to be very significant for ultimately when I run this and show you that it all works. Okay, next thing, I need to create a file called pvc.yaml, right? And keeping in mind, in reality, this would be created by 2 different parties, right? The PV would normally be created by the admin. PVC is going to be created by the user. But since I'm demoing the whole thing, I'm playing both sides. All right, so I'll put in the pvc.yaml file. Here are the important notes here. Kind is persistent volume claim for the resource object we're creating. Second thing is, notice the metadata name, pvc-local vol. Third important thing, storage class name here matches the storage class name that was specified there. Very critical that those 2 match up to one another. Access mode also, and storage capacity requests match the requirements here. I could make this on the PV side bigger, but I can't make it any smaller. Otherwise, it will not bind successfully, right? But let me save that away. And then the third file I'm going to need is this one, the pod definition. And the pod definition is the one that's going to have to, let me get that file in place, is the one that's going to have to reference the PVC. Because again, remember that so I'll put in a pod.yaml file. Remember that the pod and the PVC would be defined by the user, and the PV would be defined normally by an admin. Okay, so here's my pod definition. Let's copy that, stick that into this file. And what I've done is, I'm going to go back to the slides for a moment, just because on the slides I've indicated the arrows here with labels to the significant parts that you need to focus on to notice what matches up with what. Because the first time you see this, it can be a little bit confusing as to, especially in any YAML file, given how poorly documented the YAML parts are, can be very confusing as to what the significant parts of all of this are. So I put in labels on the slides to indicate what it is that you should fixate on. So notice back to the PV that we set the storage class name to manual, and that's got to match with the same name in the PVC to enable the binding right there. All right. Second thing, note that this name, pvc-local vol, that matches up with this name in the pod definition, which I've labeled here. Right. That's how the pod is indicating that it wants to use the PVC specification in this file. Right. And then here's the other significant parts of that pod definition that we are indicating with the container subfield, the name of the container, the image that we want to base this container on, which is that Nginx image, which I initially demoed to you as a deployment from the command line, just so you can see how it works. and the port, container port 80, and volume mounts very critically, the mount path. This mount path is specifically set to the exact location that we know that Nginx serves up an index.html file from. Okay, so that is all of the 3 major files that I need. Let's go to the command line. I'll cd to that directory where I am going to be working from for this demo. All 3 files are there: pv.yaml, pvc.yaml, pod.yaml, and let's do a kubectl apply on all 3. So apply-f on pv.yaml. All right, before I go on and create the second resource for the PVC, I want to do a kubectl git PV, just so you're able to see that the PV is there. I want you to see the before and the after. The PV shows up as pv-localvol with the appropriate capacity. This is why I told you need to know those acronyms. RWO, read write once, because of the fact that when you run this git command, you'll see a column that uses that acronym. And the earlier slide that I showed you is the decoder for what these acronyms mean if you ever get confused about it. I summarized it right there on the slide by design so that when you do something like what I'm doing now, you will know exactly what that means. And if you don't, then the slide will give you the high-level details of all the various access modes. All right, the other bit of this is the storage class name, manual. That's the other important part, right? And the other thing I want you to see is that there's nothing in here that says for the modes that it is bound, but that's going to change when I do this. I'm going to run kubectl apply -f pvc.yaml now. Right? As soon as I do that, I'm going to go back and run a git on the PV, and the difference you're going to see is the binding. It'll show that it's bound, and there you go. Under the status column, instead of available, it shows as bound now, right? And so this is why I wanted to run this before, and I wanted to run it after, so that you're able to view the difference. As soon as that PVC came around and the PV is sitting there, now it's the case that Kubernetes under the covers matched the 2 up with one another and bound the 2 together. And that's why the status, instead of showing available, now shows bound. And the other thing I'll show you is we're going to see an equivalent of that when I run git command on the PVC, which we'll do here. And there again, status is bound, right? So here's the PVC, exact same capacity, exact same access mode. That's why they're bindable to one another, and exact same storage class name. All 3 are matched up. So therefore, the 2 can be bound, and the 2 are bound, as indicated by both status columns. All right, one more thing I got to do. I'm going to run apply-f on the pod.yaml. And apply-f on, oh, I misspelled kubectl. There we go. All right, so pod is created. Let's run git pod just to verify. I have now an Nginx pod that is up and running there, right? So I've got all 3 major bits that are created. Now, how do I go about testing this? Well, what I need to do is open a shell into the node by running minikube SSH. I'm going to go to that location, mnt/data within that shell. In fact, let me do it as I talk about it. So I'm going to run minikube SSH. There we go. Gives me a shell into the right spot, into the node. Now, what I want to do is, first of all, see that there's a directory called mnt data already there, but it's got nothing in it initially. So let's do a cd to /mnt from within the shell. Okay. There's a data directory underneath there. I'll cd to there. Nothing in there, though. Let's put an index.html file into it with just some very base contents. I'm not even going to try to put a whole set of HTML in. I'll just put the string hello world, right? So I'm going to use this command to create that index.html file from within here. Part of the reason I'm not doing a full-blown file, by the way, is permission issues. I don't have permissions to write a file into here easily, right? And I have to go messing with permissions in order for me to make that happen. So this is why I can just run this. By using the sudo command, I can run this one command as administrator where I just echo out hello world and redirect it to this location, mnt data index.html. All that matters is I get an index.html file with some contents there into this location. and let's verify that it's there. So I'll do a cat on index.html, and there's my hello world string in this location /mnt/data. So in other words, it's in the host node at the mount location that we specified. Let me get out of here now. The next thing I need to do then is, given the fact that we designed this, let me go back to here, so that within the pod, the mount path that we specified was user share Nginx HTML. That means if I look there should be a index.html file, as always with any Nginx, there's one out of the box, but we just effectively overwrote that file with our own index.html file with that string hello world in it. So here's what I'll do is get first the name of the pod that we define, which is Nginx pod. I'm going to do what I've done several times now, kubectl exec-it Nginx pod --bash to get a shell into there. And we can just test it right now, and then we'll go and look at the actual file contents after that. But if I curl to localhost, I expect to see that hello world string return back. Oh, not quite. I'm still getting the old hello configure from, oh, what did I miss? That should have mounted to there. Oh, I gotta not into the pod, into the, oh, I did. I exec into the pod. I curled to localhost. It should have wiped that guy out. Oh, PV-pod. I'm in the wrong pod. That's why. So that was a user error, not an error in terms of my configuration setup. I was looking at the end. In fact, let me kill that Nginx pod. That was from the last demo. This is an example unintentionally why it's really important for you to clean up when you're done with something, because otherwise you can make a mistake like I just did and end up going into the wrong pod. So just so I don't do that again, let me delete that pod, Nginx pod, like this. All right, there we go. kubectl get pod. Get pod. I expect to see just one pod now. There's PV pod. Remember, PV pod is the one for this demo. You can see that by this pod definition for the YAML file and the name underneath the metadata field. All right, now I'll do a kubectl exec-it into pv-pod --bash. And once I'm in there, I can curl to localhost, and I expect to see here that hello world. And that's exactly what we have. All right. So that's an illustration of how you can go about configuring through this Hostpath volume type, configuring things so that you mount into a location in the node, you mount that location into the container running within the pod, and then when you put contents into the mount location in the host node, then whatever is in there is effectively in the equivalent directory that was mounted into the container. And in our case, we configured it so that it would go to that exact location where Nginx by default looks for an index.html file and then serves that straight up. One thing I promised you, and I'll go ahead and do it right now too while I'm here, is we'll go and look at that physical location now, which is user share. And then underneath here is an Nginx directory. And then in here, there's an HTML. In fact, I remember the path now. It's HTML. And then I expect to see index.html here. And then when I cat that, I expect to see hello world. Right? And there it is. So effectively now we're sharing between this location within this container running inside of that Nginx pod with /mnt/data in the host node. That's how this was configured using the persistent storage mechanism of a host path. That's the summary of what I was showing you in this demo. All right. So here is a screenshot of what I just did of the entire procedure again, so you can replicate it, but I've just done all of that in the demo. Now I want to conclude this with a couple of last things. One, I want to return back to where we were earlier in the talk, which is I showed you a list of these various volume types right here. In fact, I still have that browser tab up. I was telling you one of the problems I have with this list though is there are a lot of different options. And if you're just starting out with this, or even if you've been working with it for a while, it may not be that obvious to you as to which one to use for a given situation. And the problem I have is alphabetized, right? Which is fine if you pretty much know the name of the thing you're looking for. Maybe you don't know exact name, but you generally know. For example, if it's Azure, you know that you look in the section beginning with A. But if you don't know that, then if you don't know at all what you want to start from, or you don't remember the name exactly, alphabetical order really doesn't work so well. So what I tried to do, and these are mainly just reference slides, is try to categorize the set of volume types that are on that page. In other words, ones that are under the category of local machine, ones that are cloud-based. So here are the ones, in other words, the AWS, the Azure, the GCE persistent disk, vSphere, volume. These are all ones that are cloud-based. These ones here are the local machine ones, which we've gone over, right, in this talk. And then here are the network volume types. So I'm not going to say anything more about it other than just to tell you that I put these two slides in as a way so that if you want to go back and review it and say, well, what are the possible candidate local machine ones I want to use? Or what are the possible cloud-based ones I want to use? You can look at these slides, and then from there, find the major items that are underneath that category, and then go and look at the docs and be able to look, not on this page, you can then look at the docs to see the specifics of each individual one. So that's what those slides are for. All right. I do want to say a couple of quick words about the CSI. I mentioned this earlier, and I said I was going to talk briefly about it. Well, here it is. There's something called the Container Storage Interface on AKS. And the CSI is a standard for exposing arbitrary block and file storage systems to containerized workloads on Kubernetes. That's right out of the docs as to what the intent of the CSI is. Now, if you're working with Azure and you're going to be working with Kubernetes and Azure, then you'll be dealing with AKS. You should know that AKS adopts and uses the CSI. It can write, deploy, and iterate plugins. So that permits, in other words, exposing new or improved storage systems in Kubernetes without having to modify any of the core Kubernetes code. So I put a link into the doc page, the Microsoft doc page officially, on the CSI storage drivers that are available. So at least you have a reference to the fact that you can use, in fact, this is also mentioned on the next slide, that there's CSI storage driver support on AKS for disks, files, and blob storage. So this allows you, in other words, if you're working with Azure Storage today, let's say, but maybe you're just starting to work with AKS or you're planning to start working with AKS, you should know that you can actually use your Azure Storage services to back the storage that you're working with in Kubernetes. So Azure Disks, Azure Files, Azure Blob Storage, and also there's a CSI storage driver for the Key Vault. I was mentioning the Key Vault earlier, and that's where this came up, a brief mention of the CSI, but you should know that, first of all, number one, AKS supports the CSI, and number two, that these are available. Disks, which are premium storage backed by high performance SSDs, or standard storage backed by regular hard drives or standard SSDs. These are mounted as read-write once and available, only available on one node for disks. If you want to make it available on multiple nodes, use files. And for files, it can share data across multiple nodes and pods. It can use both premium and standard storage. And if you've been working with Azure Storage at all, you know blob storage is the storage to use if your data is unstructured and you want to economize as much as possible, which almost everyone does, right? Because blob storage is very, very cheap by comparison to the other Azure storage mechanisms. And I want to say a few words also, just to contrast what I demoed to you a moment ago with the host volume type. I want to contrast that with the host path volume type versus a local volume type. I was mentioning host path is not particularly a recommended best practice mechanism to use. The local volume type would be generally a better choice. It represents a mounted local storage device, like a disk, partition, or directory. Static provisioning for this, though, is the only available option. Dynamic provisioning is not supported with local volume types. That is one of the big limitations of local volume types. Here's the big constraint that you need to specify with the local volume type, though: node affinity. You have to set on the PV a particular node affinity, a node that you want to deal with and that PV to be associated with. It's used by the scheduler to assign the pod to a particular node. And the PV requires manual cleanup unless you're using external static provision, right? And then here is a couple other things about local volume caveats and best practices. There is a potential availability and data loss issue when you are using this. It's dependent on the availability of the underlying node, because you have to specify a node affinity field. that means that that node has to be available, right? And the pod that's using that local volume is unable to run if there's a problem with the node that you specify for the node affinity field on the PV. So that is a critical element about the limitation of a local volume, right? You use this with the storage class. You can set the volume binding mode. This is a recommended best practice to wait for first customer. That will delay the volume binding until pod scheduling time. And that allows all the PVC constraints to be considered when they select a corresponding PV. So this avoids some of the security issues I mentioned with Hostpath, but it does open up its own can of worms in that you do have to specify a node affinity, and that node has to be available. Otherwise, this isn't going to work. All right. And here's a summary of Hostpath versus local PV. I'm selecting these two in particular because these are very commonly mentioned ones when it comes to dealing with local storage of some sort. Both of these mount into a pod. Hostpath mounts to a file or directory from the host node's file system into the pod. Local PV mounts a local disk or partition into a pod. So that's a big advantage for local PV because this is more in line with what you typically want to do. But scheduling is the other important difference, that the Hostpath pod may be moved to different nodes. That can be good or it can be bad, right? The good part of it is it doesn't depend upon a particular node, but the bad part of it is this could potentially result in data loss if you're moved to a different node. Local PV pod is always scheduled on the same node. So this can be used in a more durable and portable fashion. Keep in mind, when you're using Minikube as I am, none of this matters because Minikube is using a single node cluster, right? So it's always a single node with Minikube. But if you're using like KubeADM, or you're using a cloud service where you would normally have multiple nodes, then this becomes possibly a significant issue for you. And as far as referencing differences go, Hostpath can be referenced using the PVC or inline as part of a pod definition. A local PV can only be referenced using a PVC. All right, I kind of glossed over one part of this, and I want to go back around and fill it in, which is if you run kubectl git PV, for example, you'll see that there's a reclaim policy setting here. So I want to clarify what that reclaim policy represents. These are the three major reclamation policy settings. Retained means the PV is released but not deleted when the PVC is deleted. And notice that is what this PV is set to, right? By default. I didn't specify any particular setting for that. Retained was the default that we ended up with there. That means the admin has to manually reclaim the volume. They have to delete the PV and delete the storage asset and the associated data. Another possibility is recycled. Recycled means reuse after performing a forced removal of the data on the volume. That has been generally deprecated in favor of dynamic provisioning. And the third major option is deleted, which removes the PV and the associated storage asset. It's used for plugins that support the delete reclaim policy, and this is the default for dynamically provisioned volumes. All right, here's what I wanted to show you as a last demo though, because cleanup is important, and I'm going to clean up all of what I've created here, the PV, the PVC, and the pod. If you want to get rid of this conveniently, and if you really want to get rid of all three, then you need to do it in this order if you want to make it easy, which is, and I'll go ahead and demo it. I'll do a delete on the pod, PV-pod is what I called it first. Delete the pod first. And you see the pod is deleted now. In fact, let's verify that. No pods, right? But the PV and the PVC are still around. That's the other critical thing I want you to see. So here's PVC. PVC is still there and still bound. PV is still there and still bound. So they are still there, even though the pod's gone away. This is why this differs from what you saw earlier in this talk at the beginning. The demos I did there, they were ephemeral volume types. As soon as I deleted the pod, the volume storage went away. Here, it's hanging around. So the PV and the PVC are still there. Now, if I want to delete all of this, the second thing you should delete after deleting the pod is you want to delete the PVC. Okay. So I'll delete that. Oops, I got to specify the name. PVC local vol. And now that goes away conveniently. And then finally, I'm going to get rid of the PV last. You need to delete the PVC as the PV as the last thing that you delete for reasons that I'm going to demo to you in seconds. Okay, so I'll say kubectl delete PV, PV local vol, that goes away immediately, and now they're all gone, right? So let's just verify that all of them are deleted. PV is gone, PVC is gone. I already showed you a second ago that the pod is not there as well. All three have been deleted. I'm going to recreate them now. I'm going to delete it in a bit of a different order so you can see that there's an issue involved if you delete it in any other order than the order I showed you, where pod comes first, then PVC, and then PV. So let's create all three again. I'm going to do a kubectl apply -f on pv.yaml. All right, let's do pvc.yaml, and then we'll do pod.yaml. Let's verify that all three now are around, as we expect. So we'll start with the PV. PV is there, PV is bound, right? We'll check the PVC, we'll check the pod, and all three are there, and everything is up and running. Now let me delete this in some other different order. Like, let's try to delete the PV first with the PVC still bound to it. I'm going to do delete PV, PV -local vol. And you'll see the behavior right away is different, which is it says it's deleted, but it doesn't come back to me at the command prompt. And the problem is it's not really deleted, right? It will be in the status of terminating, but it won't be deleted. So I'm going to do kubectl get PV. You'll see that that's exactly the case. The status is terminating, but it's not gone, right? Similar thing is going to happen right now if I try to delete, if I did it the other way around, if I deleted PV before I deleted the pod, I'm going to get exactly the same behavior you're seeing here. So why is it that it's not terminating right away? This is a feature, not a bug. So the way it works is, and you just saw this, it appears to hang with the terminating status unless you delete it in the order of pod, PVC, and PV. This is a feature called storage object in use protection. So the PV and the PVC are not deleted until they're no longer actively being used. The problem here is the PV, which we just tried to delete, is still being bound to the PVC, and the PVC is still being used by the underlying pod. That's why I'm not going to be able to get rid of these guys if I do them in any other order other than this order. I got to delete the pod first, so that way when I go to delete the PVC, it has no dependency. And then same thing when I go to delete the PVC's got to be gone. Now, what if I wanted to really, for whatever reason, I'm not recommending this, but I'm just showing you the feature. What if I wanted to get rid of the PV and really want to fully have it delete because it's still not gone yet, still in that same terminating status? You can actually get rid of it. You can cause it to go away, but you have to know about this. It's a finalizer setting that they put into the metadata. So I can run this right here. In fact, I'm going to steal it out of the slide so I don't mistype it right toward the end of the talk here, right there, where I'm going to run kubectl describe PVC and whatever the PVC name is. Because it's going to, the describe is going to specify a lot of stuff, I'm just going to look specifically for finalizers. So PV, I want to do PV actually. PV -local vol is what I called it. Okay, we're going to grep for finalizers because that's the only line I'm interested in the description that comes back. And there we go. It's this setting, kubernetes.io/pv-protection. That is that feature that I was just alluding to here, this storage object in use protection feature. What you can do if you really want it to go away is run this command right here, which is to set the finalizers to an empty array effectively, instead of what is already there with the PV protection. So I'll run this command with the appropriate name substituted in. So it's going to be PV-local vol, and I got to change the resource type to PV. When I run that, here's what's going to happen. It'll empty out this finalizers, and then right away the PV is going to be gone. Okay? So let's run that. When I do a get PV, I should see nothing, and that's exactly what I have. So that's the trick that you have to know about. If you really just wanted to delete these, for whatever reason you didn't get the ordering right, it's hanging around there, you could come in and delete the other resources that it's dependent upon, then it'll go away. But I just thought I would show you this for two reasons. One, if you wanted to do a more forceful removal of just that, it would be weird for you to do it. But, and I'll show you this too. Same issue I'm going to have with the PVC, sorry. If I do delete PVC, then PVC-local vol. But once again, see how it appears to hang up? Again, it's because the pod is still around. Now, one other way I could do it, I can come in and delete the pod, and then finally that will release the thing that this is waiting on. Or I could do the same trick I just did a moment ago, but with the PVC. So let's delete the pod, PV-pod, like that. Now the pod's deleted, the PVC should be gone too at this point. Yeah, and you see that that finally got rid of the PVC. Or option two, you can do this. Again, I'm not encouraging you to take out that protected mode, but if for no other reason, it's worth knowing that this exists and why it exists as a protection feature. So this is just what I did in the demo a moment ago. And that about wraps up this talk. So what we discussed in here is Kubernetes storage and how it's implemented through the use of volumes. A volume is a directory that is accessible to containers in a pod. There are a large number of supported volume types. There's the, as you saw on this doc page over here, which is this one, which I've helped categorize through that slide that will hopefully help you navigate through that if you're new to this. We talked about the ephemeral volume types. Remember that those do not hang around beyond the lifetime of the pod. And we looked at empty dir, we looked at config map. Remember about secrets. Secrets are not encrypted. It does not persist it, but it's not encrypted. So you got to use encryption at rest and ideally use RBAC as well. And then we talked about persistent volumes, which involve three major constructs. The PV, which is created by normally an admin to reflect the storage capabilities available. The PVC, which is created by the user to indicate the request for storage and what storage capabilities they need. And the pod, which is also normally created by the user. And that pod needs to reference the PVC to indicate what storage it needs. And then finally, a binding occurs between the PV and the PVC. And the restrictions on the binding are the PV has to meet or exceed the requirements of the PVC. And if it doesn't, they'll never be bound together. All right? And it's a control plane within Kubernetes that matches the PV to exactly one PVC. Any questions about anything? I am done with the talk now. So if there are questions, I will be happy to field those. Anyone want to, let's see. Martha, are you on?
I'm here. I don't see any questions.
No questions, okay.
So, nope, I think you're good.
All right, I think we can wrap this up then.
All right, thanks everyone.
All right.